Hi guys, how's everybody doing? We have our last lesson of the chapter today, and then Wednesday we're going to do a test, more to follow on what that test looks like. Just keep in mind for this test that you will be given all of the formulas. You don't need to spend time memorizing any of these. I don't know how you would memorize all of the formulas that we've done. They will be at the top of your test, just sitting there ready for you. So today we are going to do 9.5, which is geometric series. Okay, geometric series. And the first question I want to ask you, and you can pretend you're answering, or maybe you just want to talk to your iPad right now, is what is the difference between a sequence and a series? Just to get a quick refresher in your brain. So a sequence, remember, if I have numbers like 1, 2, 3, 4, that's a sequence, right? A series is when you're changing, when you are, you know what, I don't want to confuse you here. Let's do an actual geometric, since I'm talking geometric. So if I go 1, 2, 4, 8, right? I'm multiplying by 2 each time, but with commas in between. I'm just talking about the sequence. The series is when you add them together. 1 plus 2 plus, I put a comma in, it's habitual, plus 4 plus 8. Okay, so this is a sequence. This is a series. All right, so we are going to talk for a little bit about geometric series. So let's say we have A1 plus A2 plus A3 plus ... and we get to an A sub n. We would say this is a finite, meaning it has an ending. There is a last term. Remember, A sub n is your last term. This is a finite geometric, running out of space here, series. Okay, finite geometric series. So the formula that we're going to use for a finite geometric series looks like this. It's the sum of some number of terms will be A sub 1 times, and then I would do all these parentheses every time, and then you can just plug it straight into your calculator. If you don't do the right parentheses, then you need to break it down piece by piece. So just put all the parentheses in, and you can plug it in exactly how you see it. So it looks like this. A sub 1 times parentheses r, 1 minus r to the nth power, parentheses, divided by parentheses 1 minus r. Technically, you don't need to finish that one, but just to make it look nice, we'll finish it off, okay? Like I said, don't need to memorize this. You do need to make sure you use parentheses. So in this formula, let's just remember what all these things mean. A sub 1, pretend you can speak to me and tell me what A sub 1 is. That is your first term. R, what does R stand for? It's the common ratio, right? That's what we're multiplying by each time. And then n is your number of terms. Okay, so we're going to use that for a few problems here. Example 1. They're going to tell you to evaluate. Okay, evaluate. And if our numbers are 3 plus 6 plus 12 plus 24 plus 48 plus 96. Okay, so that's our series. Now here's the thing, guys. You could use your calculator. You could just plug this into your calculator and be just fine. I'm going to show you how to do it with the formula on one like this. I don't care if you do plug it into your calculator, But the formula is there because sometimes you're going to have to do 50 numbers, and you don't want to have to plug 50 numbers into your calculator. And then they get really big anyway. If we're doubling, like we are in this one every time, your numbers just get bigger. So first thing you need to do is decide, is this an arithmetic or a geometric series? And if you look, we're going times 2, times 2, times 2, and so on and so forth, right? We're multiplying by 2 each time. So we know it is a geometric series. So because it's a geometric series, we're going to plug it into the finite geometric formula. So that is this guy right here. Let's plug it in. So the sum of, how many numbers do we have? 1, 2, 3, 4, 5, 6, okay? The sum of those 6 numbers is going to be, and if you don't put that there, I don't mark you off. You can just write the sum. The sum of those 6 numbers, we want the first term, a sub 1, so that's 3, times, and then we're going to do 1 minus the r, right? R here, that's our common ratio, and our ratio is, what are we multiplying by? We're multiplying by 2 each time. So 2, and then the number of terms, we said we have 6 terms, so 1 minus 2 to the 6th power, over 1 minus our r, our rate, our ratio, which is 2 again. Okay, you are going to plug it just like you see it right there into your calculator. 3 parentheses, 1 minus 2 to the 6th power. Some of you might have to like arrow over here to get your parentheses to go around the whole thing instead of just the 6 up top. So don't forget to arrow over, divided by parentheses, 1 minus 2. And when you plug that in, and I would absolutely plug this in right now if I were you to make sure you're plugging it in correctly, that's going to be 198. 89. 189. Okay. How about this one? If we have 4 plus 12 plus 36 plus ... Okay, and then they say find S sub 10. So what that's saying is find the sum of the first 10 terms. Okay, find the sum of the first 10 terms. So what you're going to do with this, we're going to say the sum of the first 10 terms is equal to, so we want our first term, 4, times, and then parentheses, 1 minus, and now you check what your common ratio is. We're multiplying by 3 and then multiplying by 3. So this is 3 to the 10th power, because that's our number of terms, that's our n, over 1 minus 3. Make sure you put that in parentheses so when you plug it in, you get the right answer. So plug that into your calculator exactly like you see it. You should be getting 118,096. Okay. Next one. Example 3. Back to our good friend Sigma here, who looks different every time I write him. Let's say we have n equals 1 and then 2 to the nth power. Okay, now here's the deal with this one, guys. You see right here, we're starting at 1 and we're going to 5. So there's only 5 terms here, and it's 2 to the nth power. If I were you on this, I would just do it 2 to the first, plus 2 to the second, plus 2 to the third, plus 2 to the fourth, plus 2 to the fifth. All right, we know those numbers. That's not hard. So it would be 2 plus 4 plus 8 plus 16 plus 32. Really, you don't even need a calculator for this. If you want to just add it up simply, this is 20. This is 40. Don't forget about our little 2 out in front. 62 is what you should be getting, but you can always just plug it into your calculator too. When it's so simple like that, it's not really worth working through an entire formula and setting it up that way. You could, but I would just do it this way. Okay, so that's that. Part B. We are going to do infinite geometric series. Okay, so that would be like 5 plus 10 plus 20 plus 40 plus 80 and so on and so forth. Okay, it keeps going. If you think about this, if that series never ends, first of all, our common ratio would be 2, right? We're doubling. And the sum of it, if you think about what the sum of this series is, because it just keeps doubling and doubling and doubling and doubling, it's going to go on to infinity, right? There's not going to be any end to it, okay? But what if, and I think people think, oh, well, then everyone that's an infinite geometric series will go on to infinity, but this is really cool. This is really cool. What if it looks like this? 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus ... and it goes on forever, okay? Think of it in more of a geometric setup here. 1, okay, 1 circle. We need to add a half to that. So if I add a half, that would look like this. If I add a 1/4 to that, that would look like this. If I add an 1/8 to that, that would look like this. If I add a 1/16, and so on and so forth. If I kept going into infinity, right? If I go all the way to infinity, not one short of infinity, but to infinity, this actually ends up equaling 1 plus 1, or 2. Let's write it this way. Your sum will be 2. Crazy, right? It eventually fills in that whole circle because we're going all the way to infinity with it. So you can have an infinite geometric series, something you are multiplying over and over and over again, and get a value as an answer instead of just infinity as your answer. Okay? Okay, so with this, there are 2 types. There are types that converge. And in order for these to converge, your common ratio has to be, the absolute value of it has to be less than 1, which really means that R is between -1 and 1, right? So you can think of it, you can think of it like this if you want otherwise. Okay, if your common ratio is between -1 and 1, your series is going to converge, okay? That means you actually will have a sum. Not just infinity, right? So that's converge. Okay, the second one is, do you know what happens if you don't converge? If you watch the movie Divergent, you diverge. Okay, and with diverge, your common ratio, the absolute value of it, has to be greater than or equal to 1. In that scenario, your sum is going to be infinity. Okay. Sorry, my lights just turned off in my room. One sec. So many new things in this remote learning stuff, guys. What I've noticed is if I sit still in my room, in my classroom for more than 20 minutes, the lights just turn off on me. That never happens when there's students around. Okay, back at it. So in order to figure out if you are going to converge or diverge, you just need to look at R. Okay, and some of these questions, that's as simple as they ask, will you converge or diverge? Or does it converge or diverge? So let me show you an example of this. Example number 4. If we have 2 plus 2/3 plus 2/9 plus 2/27 plus ... And they ask you, I'll just write it down here. Does it converge or diverge? Okay. What you need to do here is you need to figure out what is R. Well, to figure that out, to get from 2 to 2/3, you had to multiply by 1/3. Or if you don't remember, like if you can't figure that out just looking at it, remember what you can do? You can always take this term and divide by the term before it. So some term divided by the term before it will help you to figure out what your R is. So if you did that, 2/3 divided by 2, you would get 1/3. Okay, so our common ratio is 1/3. So what does that mean? If it's 1/3, will it converge or diverge? Well, 1/3 is between -1 and 1, so this will converge. Okay, meaning you'll actually, if you were to solve this, you would actually get a number answer, which we'll do in just a minute. We're not going to do that yet on these. I just want you to check if you can figure out converge or diverge first. Okay, example 5. Let's say you have n equals 1 through infinity, and our formula here looks like this. Okay, the question is, does it converge or diverge? Okay, well, if you look at this, we have to figure out what our R is. And if you think about the setup of this, this is like our exponential growth and exponential decay, right? Our first term and our common ratio. So all we're really looking at is this number. Okay, that's our common ratio. That's our R, if you go back to your geometric formula. So if R equals 4, then think about converge or diverge. If R is greater than 1, it is going to diverge. Okay, meaning this is going to go on to infinity. Now, if you think about that, a 4, right, that's a bigger number than 1. One sec. Sorry, math teachers coming in. So anyway, a number greater than 1 for our common ratio means it's going to diverge. Okay. Okay. Last thing, letter C here. We're going to talk about infinite series. Oops. Okay. There's a formula for infinite series. So if a series converges, okay, if a series converges, then this formula works. The sum to infinity is a sub 1 over 1 minus r. It's very nice, right? Pretty neat, simple formula. So we're going to do 3 of these, and then we'll be done. Example, I wrote 3 because I said 3. Example 6 here. If we have this setup, okay, if you look at this setup right now, because this number is 1/5, okay, that's our R is 1/5, we know that will converge, right? Converge is when the number is less than 1, or between -1 and 1. So this will converge, okay? So if we know it's going to converge, then we can use this formula. So the sum to infinity, which is what we have going on here, will be, and here's what you have to do, a sub 1. So you need to plug in for your first term. Well, if I plug a 1 in here as my first term, what I get is 1/5 to the 0 power. What is anything to the 0 power? It's 1, right? So my a sub 1, I'll write it here, is 1. Okay, so my first term, which goes on top in this formula, a sub 1 is 1. And I'm going to put that over 1 minus my common ratio, which we already said was 1/5. So again, plug that into your calculator, 1 divided by parentheses 1 minus 1/5. And when you plug it in, you should get 1.25. So a series going to infinity can equal 1.25. Just nutty. It's so crazy, right? Just doesn't sound possible, but it is. Math is beautiful. I hope you're feeling that way as you sit and do math by yourself at home. Okay, example 7. Let's say we have 1/3 plus 1/9 plus 1/27 plus ... Okay, so it goes on forever. You need to figure out what is your common ratio. And again, remember, you can always do the second term divided by the first term if you don't see it, what your common ratio is. But if you look here, if I take 1/3 and I multiply by 1/3, I get 1/9. 1/9 times 1/3 is 1/27. So our common ratio is 1/3 actually. Okay, so because it's 1/3, this will converge as it's between 0 and 1. Okay. So what we're going to do is we're going to plug this into our formula. So it's going to be the sum to infinity equals, and then it's our first term. Our first term is the 1/3 divided by parentheses 1 minus our common ratio, which is also 1/3. So this one's a little confusing because they're both 1/3, but they're different 1/3. And when you plug that into your calculator, you get 0.5. Beautiful, right? It's a half. To infinity, it's a half. Crazy. I love it. All right, last one. This one's kind of cool. 0.3 plus 0.03 plus 0.003 plus ... Okay, so going on to infinity, we need to figure out what our common ratio is. Okay, and if you don't see it right now, remember, you can just do second term, 0.03, divided by first term, and what you get is 0.1. Okay, so 1/10, we are multiplying by 1/10 each time. And if you think about this, if we're actually going to add these numbers, here's just a little side note for you. What if we actually added these like this? Right? If I were to add these, you get 0.333. It's just going to keep going, right? It's 1/3 is your answer, but I'm going to show you with the formula because not everyone will just see that. So the sum to infinity is your first term, 0.3, divided by 1 minus the common ratio, which is 0.1. And again, plug it into your calculator exactly how you see it with those parentheses. You're going to get 0.33333, 0.3 repeating. And everyone knows 0.3 repeating is 1/3. Beautiful, right? Have a lovely, lovely day.